In this video tutorial, we're going to show how Adapt Builder limits the contribution of prestressing steel for flexural strength in special moment frames. And this is actually considering a provision in ACI 318-14 Section 18.6.3.5. We're going to go ahead and open a moment frame model, multi-story model in Adapt Builder. We want to make sure in the splash screen that we open the option for PTRC as the design mode. This in essence enables the ability for the user to select this option. We're going to have Floor Pro and Edge open, and we'll go ahead now and navigate to the model in question. In this model we have a multi-story moment frame, and we'll go ahead under visibility to show a rendering. It's a symmetric frame. We have several levels with the same number of bays both directions. We have beams on column grid lines. All beams participate in the lateral resisting system. So we'll go ahead and we're going to take this and look at just the lower level. This is plane 2. We could do the same for really any plane in the model. Under criteria, we're going to select analysis and design options. And when we do this, we have this option, check if fraction of bending strength of a beam section provided by prestressing exceeds a particular percentage. This percentage in this case is in the form of a decimal. So we have 0.25, which is the requirement for the code. And we're going to go ahead and enable that. This means that the design strips have to be designated as beams and they must include post-tensioning. We'll set that as OK. And the next thing we're going to do is at this particular level, I'm going to go ahead and show that we have one design strip here. We're going to limit this particular example to one design strip. In reality, the user would want to have beam strips on each one of these beam lines in the X and also in the Y directions. So in this case, we have one strip, and you'll notice I also have splitters, or I have this tributary actually bounded or split off by virtue of a new input for support lines. This is going to be included in version 2019. If I double click on this particular design strip, this is labeled a beam under the design tab. Under design section options, you can see that there are different settings here where rather than using splitters, I could actually go in and put in a tributary limit to either side of this strip. So let's go ahead. I'm going to clear out the design strip, and we're going to come back and we'll kind of start from scratch here. We're going to say to each side we're going to assume that we have a 5-foot tributary. I'll generate the sections. We'll use this option under floor design for generate sections. That generates a strip that we're going to be considering. We're also going to add post-tensioning to the strip. So we'll go over here to tendons. And for this strip, I want to add just enough tendons to meet the pre-compression. So if I look at the area of the design cut, this area is around 1,120 square inches. We're going to assume we want a pre-compression of 150, so we need a force of around 168 kips for our PT in this strip. That equals around seven tendons. So we'll add 7 tendons to this particular strip. I'll go ahead and add a tendon. I'll use snap to nearest just to snap on this slab edge, and I'm also going to use snap orthogonal so I can just align this nicely along the X direction path. I'll turn off these two snap options and then snap to perpendicular, press enter to close. Once that's entered, I'm going to change the number of strands to 7. We're going to assume an effective force of 26.7 kips. And then I also want to change the profile on the 2 end bays to cantilever down. We'll go ahead and do that. something like this. This is our tendon profile. I'm going to switch this over to a 3D view, and in the 3D view I just want to confirm loading on the slab. If we show the loads, we have a live load of 75 psf and a dead load of 20 psf. Okay, the next thing we're going to do is just analyze this slab. We're in single level mode. I'm going to go ahead and mesh the slab, and I'm going to analyze the slab. And what we're wanting to pay attention to really is a strength combination. You can see we need to add a strength combo here that does not include the lateral. We're just looking here at gravity only. So let's go back to load combos. I'm going to add one combination here. We'll call this strength total gravity. I'll change the combination type to strength, and we're going to say this is 1.2 times dead load plus 1.6 times live load plus 1 times hyperstatic. We'll scroll over to pick up that hyperstatic load case. Once the load combination is completed, we'll come back to analysis, and we're going to execute. We'll execute for that one strength combination here. We'll go ahead and select OK to run the model. Select yes to save, and then we're going to design the strips. Now I want to turn off the view of the elements, so under the visibility analysis ribbon we can turn off the shells there, and I'll select this strip, and we're going to design the design sections. After we've designed the sections in the result browser, we want to make sure we have the strength combination selected that's in question, or the envelope of strength combos. If we go to analysis under the design section tree branch here, we can select contribution of prestressing to moment capacity of beams. And this gives us the option to select either positive or negative indicators. If we go to positive indicators, we can see the contribution of the prestressing steel to capacity. Here we have 100%, for example. In the next spin over, there's 70%, and so on. So if we actually calculate the reinforcement for strength total gravity, you can see there's just a few locations where we actually need additional rebar. So the demand moment in this span, which is a longer span requiring more reinforcement to meet a higher demand, needs more rebar than the shorter spans where we may have enough rebar satisfied by the prestressing. That's why there's no calculated rebar in this span here. In the span here, the two cantilevers, the only span that requires additional calculated rebar to meet capacity is the middle span, which is the longer span. Hence, we have 30% derived from the reinforcement, 70% derived from the post-tensioning. So this tells us where we may have an issue meeting this particular provision, or the 25% that we entered at the onset inside of the design and analysis criteria. If we switch this over to negative capacity, again at this location where we have top bars on either side of this long span, we have roughly half, 50% controlled by PT, the other 50 by the reinforcement. So that's the lowest amount controlled by PT. So the program indicates these locations along each span. If we double click on the section cut, the program will give us indication in this dialog window how much additional rebar would be needed as an estimation in order to dilute the capacity such that the amount of post-tensioning only provides 25%. At this particular section, the user would actually need 10.7 square inches of reinforcement to dilute the capacity to 25%. So the user could technically take a weighted ratio of the amount of pre-stressing steel with respect to its strength and ultimately reduce this amount of PT potentially, or add this amount of rebar as a direct result of the check being made. So this, for example, is 10.7 square inches, If I go over to the span to the left where we have 100% given by the PT and double click there, you can see we need more rebar, 12.7 square inches in order to dilute that. The program does not report this amount of steel graphically. It reports it in this dialog when you double click on a design cut. If you have any questions about this tool in Adapt Builder, please contact support@adaptsoft.com.